third one's called the stapes. Learn them in order, just like that. And they're a linkage that connects the vibration on the tympanic membrane with the cochlea, which is right here. So how this works is, you hear a sound, it vibrates, which makes this bone move, which makes this bone move, which makes this bone move. Now, when you get to the stapes, what you can do is on this model, you can't tell because it's glued in, but the stapes is sitting over an open space. That open space is called the oval window. Now, the oval window is just as the same name means. It's an window, it's an opening into the cochlea. So what happens is the vibration will move this stapes, which will move the fluid inside. It's like a little pump that goes off, like a little bellows that goes off, pushes the fluid, okay? And it pushes the fluid at the same frequency as it was created, right? And that's how we can hear different sounds, different pitches. So now the fluid will go, be transmitted, and move, okay? So now the energy from the air has been turned into fluid energy inside the cochlea. And it starts to move and spread. Now what it does is it's going to move and spread, and it's going to go into the cochlea. Now this is a section of the cochlea, this thing, okay? So now what you do is you take this section, and what we did was we took this and chopped it open. Take it, okay? And we took this and chopped it open. Now this is the port we're talking about here, okay? You see this? Okay? So we have try to visualize this is one of the tubes of the cochlea, and the fluid is coming right at it. Okay? This way. Okay, now, what happens is the fluid moves and it gets caught in between this structure, which is called the tectorial membrane, and this structure, which is called the basilar plate or membrane. Tectorial membrane, basilar plate. The basilar plate contains these little hair cells. See these brushes in there? The little brushes in there? The little brushes are going to move and be deformed. They're going to be pushed over. Okay? And when they get deformed, the mechanical receptors, you learned about mechanical receptors in lecture. The mechanical receptors, they move, which depolarize the primary afferents, the sensory neurons underneath. And they depolarize the little axons, and then the information travels in the axons and leaves. And then it ends up in cranial nerve 8, the cochlear division of cranial nerve 8, right? And then it goes to the brain, which we'll talk about in a minute. Okay? So that's hearing or audition. Okay? So when you hear anything, not just speech or language, but anything, that's how you do it. Okay? So this is a sliced open cochlea. Now you have above and below, these are only used for vestibular function, right? So this middle one is called the cochlear duct or the scala media. It's in the middle. Okay? Then this bottom one is called the scala tympani. And the top one is called the scala vestibuli. You remember scala vestibuli is the top one on the model? Because this thing is called the vestibular ligament, or membrane. Okay. There's one in the larynx you'll learn about next semester too, but this right now, this is referring to the ear. Okay? So you have vestibuli, media, tympani. Scala means container or opening, right? Like Scala is an opera house, you know what I mean? Okay, so you have the middle part. This is hearing, and this is for vestibular function. Okay, now, how does vestibular function work? Well, we take, and here's the cranial nerve 8. That's why it's called the vestibulocochlear cochlear nerve. That's why I told you guys I'm going to mark you wrong if you say auditory, because it's only half an answer. Okay? Alright? It's only half an answer. You have to know cranial nerve 8 has two parts. One for hearing, the cochlea, and one for balance, vestibular. Okay? So here's the three semicircular canals they're called. 1, 2, 3. And they're anterior, middle, and posterior, but don't even worry about it. Just remember semicircular canals. Good enough. And what they do is they fill the fluid. So when you move your head, it actually sits like this, right? So when you move your head this way, the fluid moves in this one. If you move your head this one, the fluid moves in this one. If you move your head this way, move the fluid in here. Okay? Now, down in here in this base has a funny name. It's called the utricle. It's a silly name. I don't know where they got it from. It's called the utricle. It's the base of the vestibular apparatus. And in there is the same thing. There's hair cells in here, right? There's hair cells in here that deform. So when the fluid comes from this direction, they're bent this way. And when the fluid comes in this direction, they're bent that one. And that way and that way, right? So depending on which way it moves, that tells you you moved in the opposite direction, right? It's like, you know, when you pull your car to the right, you can actually feel the pull to the left. So that's where the forces are going, right? Then how the body knows how you're moving, okay? Forward, back, right, left, or spinning. That's the vestibular, okay? Okay, now, one more thing you have to look at with this model, which is the couple other parts. There's one other important part here. It's right here. This is called a eustachian tube, E-U-S-T-A-C-H-I-A-N, or auditory tube. They're both correct. And here's the auditory tube or eustachian tube. Now what this thing does is, it connects the middle ear and inner ear with the pharynx. Okay? Because this is a little tiny area, little tiny set of tubes and canals inside the skull, inside the bone. Okay? So if pressures ever built up, that would cause problems. Okay? So now, this is designed to equalize the pressure between inside and outside, because when you have a small container, the pressure can go up very quickly, right? So, the eustachian tube or auditory tube balances that. How do you remember that? You ever swallow and you hear your ears pop? Same thing. That's why. Okay? Like when you're coming down in a plane, landing in a plane, right?
Can you repeat what connects the middle ear?
It connects the middle and inner ear with the pharynx. That's why I always have to, before I got my noise canceling headphones, right? Which is probably the best purchase I ever made, which I gave to my son when he went to school, because I don't really need it anymore, because I can't, now that I'm destitute and almost homeless, I can't afford to fly anywhere anymore. So, I'm minutes from being homeless, so, you know, I can't afford to fly anywhere. So I gave him my wonderful Bose noise canceling headphones, which is probably the best purchase I ever made. You ever seen them? They're awesome, right? You turn these things on and you hear, that's it. You can't hear a thing. I mean, you're sitting on top of jet engines and you can't hear them, right? It's so good. Right? But anyway, so before I got those, I used to dread when I get on a plane and there was a little baby sitting around me. The worst. Because they're always going to cry when they go up and down. Why? Because it hurts, right? Because they have little tiny, baby-sized eustachian tubes that don't really work very well, right? So it hurts like you know what when it goes up and comes down, right? And that's why they're crying. Plus the parents are the worst too. So actually, it's not even the baby, it's just the parents are the worst. I can't stand most parents. They're the worst. Anyway, I don't know why they use it in the first place. That's just my issue. Okay, so now, you know what I'm talking about, right, Rose? The worst parents.
You just want to say something.
You know, you just want to crush. You want to punch them in the face. You know, the kind of people that will take a 9-month-old and go to a 10 o'clock movie on Tuesday night with it, and with the kid, and then wonder why the kid's crying, and they get annoyed at the kid. It's like, you're a moron. Put him in his crib where he belongs, and go away. You know what I'm saying? You are a freaking imbecile. Go away. You bother me. Anyway, that's okay. Record it and put it on the internet and publish it. Put it on YouTube and publish it. So everyone will know the truth. Anyway, so now, right, Anthony? Put it right out there because people got to hear the truth. Anyway, so remember to put it. So remember to do that. Okay, so look over those structures. Okay, so those are the basic structures for the year. I did the I last week. Study them. I gave you the pathway, neurological pathway for the I, and I'm going to give the neurological pathway for the ear and right now. I guess I'll just do it now so you can study the whole time. Okay? Here we go. That's like when I call Chase and complain that they messed stuff up. I say, first thing, how